Good afternoon and good morning. I'm Pete Costello and serve as Kodiak Technologies Director of Airport Operations. Welcome to our webinar, Electrifying Snow Removal Equipment, Advantages and Applications, which is the first in a series of webinars that we will be offering. This webinar is being recorded and will be made available to attendees after the event. During today's presentation, please use the Q&A feature to ask any questions that you may have, and we will try to answer them in the session or afterwards via email. At this point, I would like to introduce our speakers. Matthew Chang is a professional engineer and visionary leader with 2 decades of experience who founded Chang Robotics in 2017. As the founder and principal engineer, Matt drives transformative projects such as autonomous mass transit systems and autonomous manufacturing, which showcases his expertise in transformational technology. Shane Pierce is the Vice President of Sales and Marketing at Kodiak America, and for the past 25 years, he has managed manufacturing sales and built relationships with businesses and consumers. Shane's strength is in building trust and strong bonds with fleet managers and operators on a regional, national, and global scale. This is a schematic of Kodiak Technologies EV snowblower that we're going to be talking about today. And with that, next slide, Shane, the floor is yours.
Well, good morning, everybody. Good morning for me or for anybody on the West Coast. We're just coming into the 11 o'clock hour. From my perspective here, what I'd like to do is just kind of give everybody a brief overview of who Kodiak is, if you're not already aware, and really the need for innovation in snow removal. So Kodiak, we've been around since 1969 initially. Kodiak America was born in 1971. So we're going on 55 years building commercial snowblowers. And in those 55 years, the technology here has not seen a lot of change. And so we are under new ownership as of 2021. And with that new ownership came really a focus and goal to update what Kodiak has always been without compromising the build quality and the strength of the machine that has made Kodiak really the heavyweight dominator in the marketplace. And so, mechanical innovation, really taking a look at where we've been and where we're going, looking at things like shear pins and clutch assemblies, belt drives, the adaptation of DEF systems and DPF and all the things that have kind of come along technology wise in clean running machines, clean diesel power. And now in today's world where electrification is definitely a conversation that we all have to engage in. We're looking at everything from an engineering first standpoint. And what that means for you as fleet managers, operations, the guy running the machine is that what makes the machine work consistently and work reliably throughout your shift or the snow event that is happening. Safety, how do we make sure that the machine is operating as it should, but in the safest possible way. The operator experience. So I've heard again and again and again since joining Kodiak about a year and a half ago, is that operators in general really like working with Kodiak. They're easy to operate, they make a lot of sense, and we're starting to update those systems as well, moving from a platform that we've used for a long time into a new, a little more point and click, if you will, much more ease of use. Environmental impact and electrification, I think we'll cover that in future slides. But just looking at, burning diesel versus the instant torque and instant power of, much more clean and efficient electricity, reducing cost. And so we look at this a couple different ways. We're looking at, if we can be more reliable and keep you running smoother and longer and reduce, mechanic and or parts costs, I think that's what we're looking at from an engineering first standpoint is how do we build it better? And then, compliance with regulations, specifically with FAA, when we start looking at, bid requests and or regulations that we have to match for tonnage, for Buy American policies, that those types of things that we've listed is that, we are proudly built in the USA. Actually, we're built in Southern Idaho, where we have been for the last 50 years, and building machines that can produce the quantities that you're looking for in your tonnage. You can kind of see this machine. This is a test for a loader mounted machine that you see here. This machine this machine has an X15 in it. It's a 700 horse machine on a 4852 size reel and impeller. And this machine on a loader will produce 7,000 tons per hour of snow moving capability. So it's an impressive machine. We test everything in water because that also gives us the best gauge for being able to move snow, because water is the heaviest thing that we will move with a snowblower. So we kind of covered, Kodiak America was established in 1971. We've served over 40 airports. We've exported to multiple countries around the globe, 8 to be specific. The electrical conversation that we're going to engage in today, this really began in 2022, with conversations with with multiple vendors that we've had in the past, and continue to work with today, including John Deere and Cummins, and bringing Kodiak Tech in to help us really navigate this conversation. Again, we're made in the U.S., based out of Southern Idaho in Hayburn. We have a new state-of-the-art facility. We've always been known to be in Burley, but we've moved just a little bit north of there, in a new facility in Hayburn. The new hybrid machine we're looking at, that we're in the midst now. The frame and chassis are being assembled for a preview and an unveiling, if you will, for the 24-25 snow season, and working on autonomous control. And I think Matt will speak better to that as we get into the next slide.
Matt Chang here, founder of Kodiak Technologies, and what we decided to do in the formation of this company was to carve out the technology element and the electrification element as a new company, to help us go faster. And then also, we've seen from around the country what it looks like when you try to reform a diesel equipment company or a gas-powered company into an EV company. It can be a little clunky at times. So in order to go fast, we've taken a technology-first approach. And we started off with the requirements. What are the requirements? Well, environmental benefits, okay? That's probably the number one thing with the EV conversion, is converting from a fossil fuel to an electric and battery electric vehicle. So that reduces our emissions. The vehicle that showed you is a hybrid vehicle, which is going to cut emissions by more than 50%. And depending on operating conditions, can go up to 70% reduction in fossil fuel emissions. A noise reduction, we're just going to run quieter and smoother. It's going to be more comfortable for the operator. The reliability is key here. And so a question that we often get asked is what sort of temperature ratings does the vehicle have? We have an excellent thermal management system, which we will cover in depth in future webinars. And all of our design ratings are rated at -20F. And so what does that mean? If it's colder than -20F, we're going to use a little extra battery pack to keep that vehicle nice and warm. And so we'll burn off the battery a little bit faster to warm up the vehicle. If it's warmer than -20, we're going to get better performance because we're not diverting as much resources towards the thermal management. Shane talked about the instant torque available with electric. We're not going to have to run up a diesel engine curve here. We're going to have immediate and on-demand power available to all of the motors, including the blower motor, so that the torque should be an immediate benefit to the operator and make the vehicle much more comfortable to operate even in tough conditions. And then, of course, cost savings. We're going to lower operating costs. We're also going to lower CapEx cost, and we're going to do a future webinar dedicated to recruiting federal grant funding to help offset the cost of this CapEx purchase, and then reduce maintenance costs. The current state for the industry is very high maintenance, very high touch. Breakdowns are frequent. And with electric vehicles, there's just so much fewer parts. There's less things to break down and less maintenance required. So it should be an easier vehicle to own and manage. And then what are the advantages of electrifying snow removal equipment? Well, regulatory compliance. Every airport has sustainability goals. And the federal government, the FAA, the EPA, and countless other agencies have set targets. And then airport CEOs are setting their own strategies to be in compliance. So we're going to help airports right off the bat by lowering the emissions of their ground service equipment and helping them meet sustainability goals. The next is energy efficiency. So our first vehicle in the prototype is a plug-in EV. Why? because it doesn't require any electrical infrastructure to operate, and the vehicle is capable of charging itself off of diesel fuel. That vehicle is going to be opening up for limited purchase later this summer for pre-orders. And then, of course, we already have a design and we already have a supply chain in place for a full EV vehicle. So for any airports that are aggressively getting into the electric charging space and will have the infrastructure available, instead of delivering a hybrid, we can deliver a full EV. Another advantage is electric vehicles are by definition software-enabled vehicles. Shane mentioned modernizing that old kind of analog experience to something more point and click. And so integration with smart systems becomes possible. Airports can actually monitor what's going on, and new features are available from the vehicle, such as telematics. And with an EV that is just built in from day one, there is no retrofit required. The automation potential is also huge. As airports begin to electrify ground fleets, they're now going to have the opportunity to automate operations. And automation, I can say this as a person that automates factories and hospitals and cities for a living. Automation is a long journey. It's not a light switch. It doesn't happen overnight. And so what any strategic airport should be looking for is a sequence of beginning to automate the airport operation so that over time you gain efficiency and cost advantage. And what the result is an empowered workforce. The workforce is upskilled, the workforce is empowered, they're trained on state-of-the-art technology, and they have portable job skills and higher pay to go with it. And then finally, the enhanced safety. By definition, a 7,000 or 8,000 ton per hour machine that is clearing snow can be a dangerous machine. And so the other benefit that we have by going battery electric is that we're able to equip and outfit the vehicle with more sensors and more human safety features that are going to make it a win-win for the workforce and for the airport. So how did we get here? That's a big question. And this was a tough journey because we were trying to comply with several things. One, we wanted to maintain or enhance the rugged nature and the durable nature of a Kodiak self-propelled machine. The other was that we wanted to have a 100% American-made supply chain. We wanted to be a Buy American compliant company that's eligible for federal funding. And that's no easy task because in the heavy duty market, it's still very early in the country and very few producers are located in the United States for our major component parts. So here we show you just a little bit of map of some of the key components. The engineering is performed by Chang Robotics. So we're taking a technology first approach. The manufacturing is being done in Idaho. And as Shane mentioned, the first prototype is rolling off the assembly line as we speak. A systems integrator, we looked for who knows about reliability, and we went to the automotive industry's most trusted partner, which is Roush. And Roush has dedicated a team developing our EV powertrain for us and the software required to power the vehicle. For power systems, we've partnered with FPT Fiat Powertrain. And for batteries, we're buying American-made batteries from ABS out of Ohio. And to make sure that we're not missing something, we have brought along with us a pretty powerful think tank. And across the bottom, you can see some of the very prestigious institutions that are helping us on our journey so that we can bring the future to our customers and have it right the first time. Additionally, once we deliver the vehicle, the journey is not over. It's actually just beginning. And so what we wanted to do is ensure that we have partners for operations and execution to help our customers. So we have two very influential partners. We have Merge Electric Fleet Solutions that specializes in helping companies that have large fleets migrate to electric. So think of them as an operations partner. And then we also have the nation's largest electrical subcontractor, Miller Electric. And why we have them is because a lot of the electrical componentry will require a new type of service agreement. So between those two companies, we can bring a full service offering to our customers for the lifetime of the asset. And next, we're going to get into the weeds here a little bit of what goes into building an EV. You've seen some companies do a rip and replace. Hey, I had a gas or diesel powered engine. I'm going to pull that out. I'll put in a battery pack and an electric motor. Well, those vehicles don't sell well and they don't perform well. And you haven't seen proliferation of retrofits. It requires kind of a ground up rethinking of a vehicle to make this conversion. So you can see just here on the left, the system architecture, some of the rethinking that we had to engage in through the design and engineering process to bring this vehicle to reality. we have a new cab in the vehicle. So it starts with the operator, and the experience of the operator should be state-of-the-art controls and lots of real-time information that empower more efficient operations. That then couples with a user interface, the UI. Does it look like a smart vehicle? Does it feel like the operator is driving a piece of technology? The quiet part behind the scenes is the EV software, which ensures that everything is operating as designed. And this is a fly-by-wire type of vehicle with a similar architecture to the Tesla Cybertruck. So having reliable software is important, and the EV software package that we're deploying with this has been in commercial service for more than 15 years and is continuously getting updated. Those updates and future updates are something our customers will benefit from. Electrical safety and EV integration. We've seen that there has been some high-profile failures of electric vehicles, especially when you get to large size such as buses. So we need to make sure we have a safety-first mindset, and we have built that in. We moved down to the battery management system, and the battery, we talked about thermal management, and there is just a tremendous amount of power stored in these vehicles. So one of the things we have to do is efficiently charge the vehicle and then efficiently dispense that energy to the motors for the operation. So we have invested in a very state-of-the-art battery management system and a very reliable battery pack system. The e-motors and powertrains are next. This is a real challenge because the heavy-duty battery electric market is not very mature yet. And so we've partnered with the very best in the industry and companies that can offer long-term warranties and guarantee of in-stock parts. The chassis development is a mechanical innovation. And as Shane mentioned, we are producing the first prototype right now and expect to ship that vehicle for the electric system installation in Detroit. We expect to ship within 7 to 10 calendar days from now. And then finally, the front-end tooling. The front-end tooling is the purpose of the vehicle. Being able to auger and blow snow is the point. And so what we've done is we have included new mechanical innovations and additional robustness in the front-end tooling. Some of the elements of the front-end tooling actually became easier by migrating away from a hydraulically driven system like most of the industry is now. And we have removed all those high-pressure hydraulics from the vehicle. It is now electrically driven, which simplifies things greatly. Fewer breaking parts, no hoses to burst, no hydraulic leaks. And then also we were able to outfit that front-end tooling with a sensor suite that gives the operator real-time feedback on the actual snow condition and the torque that is being experienced in the snowblowing operation. So as part of the EV transition, this is a national conversation. Infrastructure is required. Ports and airports specifically have a strategic advantage because they have a property line, they have a boundary. And so it is much easier to create an ecosystem inside of a boundary than, say, the entire national highway system. So with this infrastructure, we have taken into account hydrogen. The vehicle is available in a hydrogen fuel cell option for any airports that have green hydrogen production on site. The battery electric storage system can be deployed. The vehicle can actually operate as backup power to the airport. So if a airport was to buy a fleet of Kodiak technology vehicles, and those vehicles could be connected into the battery electric storage system of the airport and serve as backup power for the airport. The charging infrastructure, this is something that we can design and bring to our customers on a consulting basis or provide if the contract allows for that. And this will take all the guesswork out of what it means to charge the vehicles. Our charging system is heavily informed by a technical team that deployed the original charging systems for the largest electric bus systems in the country, which are in service all day, every day, and require top-up charging from time to time. And so we'll be bringing that thinking and that technology to our customers. Power management system. This is another area that should be on the strategy roadmap of every airport, and that is to have real-time knowledge of the power consumption of the entire airport and all the power-consuming devices. There's been a lot of press about EV chargers in a rental car facility, and what impact does that have? Most airports now have the solar panel somewhere at the parking garage. So as airports become more conscious of energy consumption, and that becomes a larger line item in their annual operating expense, especially with rising power costs, how are we bringing data back to our customers so they can make informed decisions? A power management system also enables the use of AI to manage power at an airport. So this is the base level infrastructure required to one day build up to AI. And then finally, communications. We have a diversified communications program on this vehicle. The vehicle will be able to report certain things securely back to the airport, real-time telematics, real-time fleet operations. That'll be in a cyber-secure environment behind the firewall of the airport. And then it also enables the export of certain data for cloud-level analytics. And again, when we think about going to autonomous or going to AI, we have to have those communications in place to enable the next level of digital innovation. So what are the major milestones? Well, heading into the snow season last year, we completed our design and we validated that from an engineering standpoint, the vehicle works. Currently, we are in the procurement of all the componentry and the build of the vehicle. And we have now placed 100% of the subcomponent orders. We have over 100 contracts in place with vendors from around the country to supply different components for the vehicle. And those are all being assembled in Idaho as we speak. And as I mentioned, the vehicle will be headed to Detroit to the Roush facility soon, where it will get outfit with the electric system. And so that work has been completed. And then what we look forward to is at the end of this year and heading into the snow season that lies ahead of us, that we'll be in commissioning and testing and ready for a road show. And in a future webinar, we'll be opening up the opportunity for select airports to apply and to have us demonstrate the technology at their airport in the actual snow environment, which will bring awareness to the technology and let operators experience it firsthand. So what is the business case? Why does this even need to happen? Well, we all know the cost of having runways shut down. As an average, and of course for larger airports it's higher, but as an average across the industry, it's $60,000 per hour that in a runway shut down. So for a 5 runway operation, you can multiply that number times 5. That's just the airport cost. It doesn't even take into account the cost to the passengers who may experience delays or misconnections, and the airlines who are losing revenue when they're not flying. And we look at what the FAA has to say, and it's no news to this audience that the FAA requires a robust snow and ice control plan, which includes heavy-duty snowblowers. And so because it is a requirement of the FAA, and because there's a financial incentive, we were driven to create a solution to take the marketplace to the next level. And how do we pay for it? Well, Shane articulated that there are operational cost savings, and that helps. As we lower the cost of airports to operate over time, that's a benefit to every single airport. However, at the moment, there is historic stimulus funding opportunities where the federal government will help the airports pay for the acquisition of electric vehicle GSE and for the associated infrastructure required. We have outlined some of the programs available on this slide. There are even more. And we've met with the FAA specifically to understand what the application process is for some of their new and emerging grant programs that are coming out almost on a monthly basis. But what every airport operator should see is that there's historic funding. And so now is the time to move to electric. Now is the time to get the federal government to partner with the airports to help pay for the electric conversion and then enjoy the benefit of a lower cost of operations over time.
Thank you, Matt. Thank you, Shane. Appreciate that. We are going to be talking on an upcoming webinar more details on the FAA grants, but should you be going through that process right now, Kodiak Technologies would be happy to write a letter of support for your grant. We can provide a insert on the technical application of green technologies, work on the costing breakdown, and there's my contact information if you want to send me an email. Be happy to get assistance as you guys are going through the grant writing process. As I mentioned at the outset, this is the first of a series of webinars that we're going to be presenting. We appreciate you all participating, and there'll be a chance for Q&A here in a moment. Please use the Q&A feature on the Teams here to populate some questions for our speakers and myself. The upcoming webinars, the next one, we're going to look at the prototype, take a deep dive on the technology, the specifications, what kind of things we can expect from that in operations in the field. We'll look at the electrification infrastructure needs for snow removal. Again, that deep dive into FAA grant process. Safety, obviously Matt and Shane both highlighted safety. That's paramount. We're going to talk in detail on that. And then implementation, right? For electrification, automation, what are the things we have to look at in airport operations for those? Then go on to maintenance, best practices related to that. As Matt mentioned, maintenance costs should be reduced, but still there's going to be new things to deal with the batteries themselves and the charging and infrastructure and all that. And then lastly, we're going to wrap things up more focused on the environmental benefits, which we've touched on throughout. So with that, we've opened up the Q&A. Looks like people are putting some questions in there.
Yep. So we've got a question that says runtime on the battery and charge time.
On the hybrid version, the vehicle is designed for a 10-hour shift, and it is designed around a 20-minute crew rest after every 2 hours of continuous operation. So the design is minus 20 F and 2 hours of continuous full load condition of 8,000 tons per hour, and then a 20-minute crew rest. And we'll remind you that because it's a battery electric vehicle, it's designed for what we call in the industry opportunity charge. So the vehicle is actually charging and recovering battery pack during that crew rest, which will enable it to get back out on the next 2-hour session and work. So in theory, this vehicle can work indefinitely under that sequence, 2 hours of full load condition, and then 20 minutes of crew rest. In the event that it's a busy airport where the snow removal team is taking a break in between landings, then the vehicle will not have to charge at all in the hybrid model. And in the full electric model, it will have to charge intermittently during the breaks to land airplanes.
Okay, another question. What led you to create a heavy-duty battery electric vehicle from scratch? And was someone else already doing this?
Well, that's a great question. I think what led us to it was a couple things. Number one was customer demand. We were asked by several existing Kodiak America customers. And the other, as Shane mentioned, was Kodiak America came under new ownership in 2021. And this initiative was started in 2022. And so I think what they're looking for is to add new life to the company, a new brand image around technology and safety, ease of operations, and lower maintenance cost. And one of the natural conclusions was to explore electric as an option. Shane, I don't know if you have any other feedback on how we got here.
Yeah, I think that sums it up perfectly. As part of the new ownership group coming in, it was really about identifying where the largest challenges have been over the last, decade, 5 years, 10 years. Identify what the best solutions to those problems are, and then how do we move to the next level? And electrification answers that question really the best.
Great. One more question. Have any airports utilized FAA funding to help purchase electrified ground service equipment?
Yes, there are existing funding programs that we'll unpack in our funding webinar, but those programs are in place with existing grant calls from the FAA. To purchase electrified equipment and ground service equipment for airports. These have already been used to purchase electrified buses to be as circulators in the airport ecosystem at the larger airports. I was just traveling through Atlanta, Hartsfield, Jackson, and saw that they had begun to install their first wave of electrified baggage carts. So there is select technology at airports that is already becoming electric at a pretty fast pace. Most of it is in the lower power category. And then in the case of buses, which is in the similar power band that we're at with Kodiak Tech, it's happening, but those are with existing products that were already being used in transit applications by cities. So what we see here is this is just us taking it to the next level, which is designing purpose-built vehicles. And one of the things that we're going to be doing post-deployment of the electrified snowblower is that we're also going to be taking that same powertrain and making it available for other heavy-duty applications. In addition, we've recently met with the federal government and the Department of Defense, who has purchased an electrified fire engine already. And so there's already several use cases in the market where airports are looking forward to the electrified future, and they're already making their first purchases on fleets.
Great. Another question. Will you have the rotary on display at the 2025 Snow Symposium?
As was mentioned, we are looking to have a road show at the prototype. And Matt mentioned we're going to be asking airports to apply to have the vehicle there. And I believe we're planning the last stop in Buffalo at the Snow Symposium in 2025. That's the plan right now.
That's right. And to add to that, Pete, yes, it's going to be a complete vehicle with our new rotary head. The rotary head is new primarily for two reasons. I mentioned that we've beefed it up and added sensors to it, so that's an upgrade. But it's primarily new for two reasons. Number one is it's an electrified blower head. So it's an electrically driven blower head, which gets the hydraulics out of the mix. So that's an important update to the industry that's going to add a lot of efficiency and reliability. The second reason, and Shane, you may want to talk to this in depth, is that we're going to be featuring our new clutch design, where instead of having shear pins that are a failure mode for the vehicle, we're actually going to have some easy to reset features for operators.
Correct. That's one of the features that we're starting to include now on every new build, after really looking and engineering the existing Kodiak machine that lots of people already know, have, and love. And so bringing in the slip clutch now replaces the shear pin assembly with an adjustable clutch that can provide feedback directly to the operator. And in the case of, hitting something that, gets buried under the snow, something else gets in the way, it stops your reels from turning. The clutch will now slip so you can back away from the problem. Quite literally, you back the snowblower up, clear the debris, and the clutch will re-engage without the downtime associated with replacing held on delivered machines. And the feedback so far has been absolutely astounding. So we're super excited to be able to move forward with, changes like that.
And Shane, I just have a follow-up question. Do you have some of that new blower head assembly in service right now?
We do, yes. Yep. On the torque clutches, we've delivered. We've had a couple different machines that have delivered in the last 60 days, actually, with the new torque clutch in it.
Outstanding.
Another question. Will the FAA cover deployment of electric charging for our new snow operations with existing grants?
Yes, I'll take that one. And that is, again, a bit of a preview, but this is good content building for our webinar on funding, which is the answer is yes. What's the cost of entry? Airports have to apply. So there has to be an application. And that's where Pete mentioned that he's your point of contact for information to include in the grant, letters of support so that the FAA can see that you have a vendor community that's supporting the initiative, and then also the expertise of getting it right. By definition, airports don't have a bunch of extra power. And bringing in all new power to do a full electric conversion at an airport would be a utility scale project that could take 5, 10, or more years. And so one of the things we look forward to is how to deploy a technology I mentioned earlier, which is battery electric storage system. How can airports passively harvest and store energy when they can buy it at the cheapest, such as at night, and then deploy that energy during high periods of use when you're running fleet? And so that's what we'll be consulting with our customer airports on, is how to do that. If they have an existing engineering firm engaged through a master procurement, we can deliver a concept design to the existing engineering firm for deployment that would be compatible with our equipment and other heavy duty pieces of equipment that'll be bought in the future. Or we can take the lead on that, and we'd be happy to design that and engineer that for the airport. That would be covered in a large part, I can't say 100%, but in a large part by a capital improvement grant from the federal government to the airport. And the other benefit, as I mentioned, is this then sets off the electrification journey. Once you can charge a Kodiak Tech vehicle, you can charge any vehicle on site. And so investment in that initial charging infrastructure will enable the conversion of additional vehicle types in the future.
Great. I think there's one final question, but you might have answered it just now. It says, if we only have electric vehicle charging in our passenger parking areas, how can we charge your vehicle?
That's a great question. This is the number one reason that our first prototype is a hybrid, is because we don't require charging infrastructure. With the hybrid vehicle, it's a battery electric vehicle, but it has a generator motor on it that charges it. So the vehicle charges itself. Additionally, we have a variety of charging options on the vehicle. We're coming in with a diversified set of standards for the charging. So in the maintenance shop, the vehicle could be charged off of a welding plug. So it can charge as low as what you see in a lot of grocery store parking lots, which is a 220 volt, 32 amp circuit. And we can go all the way up with this vehicle to what's known as MCS, which is megawatt charging standard. So if you kind of think of the different tiers, you could charge with as little power as a welding plug on a 220 volt outlet. You could move up to what Tesla calls the supercharger, where they're charging vehicles at fast rate. And you can go a level above that, which is where the newest electric buses are, which is called MCS, megawatt charging standard. So we'll be able to take all three charge types on this vehicle, making it easy for any operator to charge with whatever they have on site. And then you don't have to upgrade. If you do install more robust charging infrastructure, then you'll just charge much faster.
Great. And we actually did get one more question in. It says, are the chassis mounted blower class 6 blowers?
I believe class 6 is the top class with the 7,500 tons per hour.
Yeah, so I'll take that. So the blower head is already rated at 7,500 tons. And that's just a legacy rating. And as people in the industry know, these things are difficult to classify because the only way to test it is to test it in the environment. And then in addition to testing it in the environment, you would have to have accurate readings of what the snow is. One of the foundational pieces of IP and existing patents that Kodiak Tech has is the ability to measure and classify snow as it passes through the auger and the blower head. So the Kodiak Tech vehicle is the first vehicle on Earth that will actually rate for the user how much snow you're moving and what the weight of the snow is. We'll be able to characterize the snow based on density, how icy it is or fluffy it is, et cetera. And so our engineering calculations are that this vehicle is rated actually at 8,300 tons per hour. And so, as I mentioned, that will be borne out by the operation, but we're going to exceed the power requirement necessary to meet the highest FAA standard. And Shane, I don't know if you want to maybe close us off with some of the testing that you do on new units to verify the power.
So testing wise, we take, depending on the season, if we have snow, we go to the snow. If not, we go to the water, like you saw on one of the first slides shown is we set up every machine, we move water with it, and water per cubic yard, significantly outweighs the heaviest snow that we work with. And so, we're setting up, tests in that environment, or when there's snow on the ground, we can test that way. And kind of as Matt has referred earlier in this question, snow is the variable. So, snow can weigh as little as 30 pounds per cubic foot, all the way up to, over 70 pounds per cubic foot. And so those ratings are always the variable on what, each individual snowblower is capable of blowing. And so engineering calculates those totals for us. And then once we get to actual testing, we test against the actual medium that we're on to make sure that we're meeting the requirements set forth by the FAA and what engineering says we should be able to blow. So testing is all hands on. So it's all there. Our engineers are on site and we start the machines and we let them do their job. And then they go to work with their calculations and their measurements and make sure that we are meeting the specs.
It looks like we don't have any further questions. We appreciate everybody attending and your time and attention. Thank you very much to Shane and Matt for this very educational and informative webinar. Like I said, we'll be in touch with our whole webinar series that's forthcoming. Yeah, thank you. We appreciate you all attending and listening, and look forward to helping you all with electrifying airport snow removal operations. Thanks a bunch.
Thank
Thanks,
you,
Pete.
everybody.
Thank you.